Welcome to this episode of And So It Flows. I'm your host, Nicole Krawcke, Chief Editor of Plumbing and Mechanical and PM Engineer magazines. Today's topic of discussion is water infrastructure, and we're joined by the International Code Council's PMG Executive Director, Matt Sigler. Matt, thanks for joining us today.
Yeah, thank you for the invite.
So before we get started, why don't you tell our audience a little bit about your background in the plumbing industry and what you do with ICC?
Sure, glad to. Yeah, well, my background is my formal education is really in construction management. That's how it started off. That's what I went to school for, got my bachelor's in. And first 13 years of my career, I worked for a home builder doing many different things. But towards the end of my time with that builder, I started to kind of get pigeonholed into a direction and involve codes. The builder I worked for built in multiple states. We were a private builder, so we did a lot of value engineering, and so we needed to know the codes very well. But we also wanted to influence what got into the codes, and so I was kind of the one appointed to take the lead on that. Well, after the builder I was with, due to the recession that hit us in '08, I believe, 2008, they had to close their doors. And I get a call a few months later from an organization I didn't know much about at the time, IAPMO. And things progressed, a flight to California. Next thing I know, I'm heading up their plumbing efforts with their UPC and their swimming pool code for the organization. And that occurred for about 5 years. And then I went and got an opportunity with Plumbing Manufacturers International, where I was a technical director, basically overseeing items and matters of interest for manufacturers. And then not even last year, it's now been over 18 months. I get a offer from ICC to join the organization. And so all in all, it comprises about 25 plus years of being involved with plumbing, mechanical, fuel gas codes. And so that's kind of why I'm here today. As regarding my position, it basically, my main role is I'm responsible for establishing plumbing, mechanical, and fuel gas related growth strategies and business plans for the organization. Along with that, I oversee our PMG technical resources team. And this team supports our membership and industry professionals, specifically when it comes to training, education, assisting in the adoption of our most up-to-date codes and standards.
Okay. So kind of getting into talking about water scarcity, when I was researching this topic, I came across a study from 2019 by the World Economic Forum. And in this study, the US ranks 23rd when it comes to water and electricity utility infrastructure. Now, given that this study is several years old, do you think this is an accurate representation of our water infrastructure today? And if not, how do you think the US compares to other countries?
Yes, I would agree with the report that the U.S. has a lot of work to do to get our outdated water infrastructure up to date. In fact, as recently as 2021, the American Society of Civil Engineers issued a report card for America's infrastructure. And in that report card, they graded the country's drinking water infrastructure a C minus. This grade was mainly due to the 2.2 million miles of underground pipes in the U.S. that deliver drinking water to our homes, businesses, and communities that is aging and underfunded and causing health and safety risk.
Okay, so drinking water is definitely a problem. Where do you think, the biggest problems lie with our current US water infrastructure?
That's there's a lot of answers to this, but the one that I think I hear the most about is the amount of potable water we lose daily due to leaky pipes, which, again, according to the American Society of Civil Engineers, is approximately 6 billion gallons per day. Um, this goes back to the reason why it's so important to replace our antiquated pipes, meters, etc. But of course, it takes money to fund these efforts, which in the US, the financial burden to replace pipes, etc., usually falls on either the utility and or government. As consumers, we generally only pay for the cost of the water we use versus the total cost of water as regards to getting it delivered to our homes and places of business. In other words, the infrastructure. I just came back from a trip to Israel, which was very insightful, and they actually charged the real price and real cost of water over there, which really is, you think about that, wow, do I really want a higher water bill? Well, it's really not that bad the way they have figured out. Now, again, Israel's the size of New Jersey, so you can't compare it to the whole U.S., but they set an example there. And by them charging the real cost of water, which includes not only the water that people use, but the entire infrastructure to maintain it, um, the water authority, who oversees the country's water infrastructure, has the necessary funds to replace utility piping when it goes bad or every 17 years, whichever comes first. And for meters, at least every 6 years. Here in the US, we have no such regulation on when to replace water service lines. And typically, what I have found out, at least was shared by some of my colleagues that were a part of the US delegation over to Israel, it's very common that utilities don't look to replace water meters any earlier than every 15 years here in
Wow.
the US, which means we have a lot of existing meters that are probably not providing a whole lot of high level accuracy.
Especially given the advances in technology and how like that changes, that accuracy reporting.
Absolutely.
So where do you see the greatest threat to public safety? Would it be drinking water, wastewater, or stormwater, and why?
Well, because we're limited in time, I think I'll just focus on one. I think drinking water is probably number one because, of course, we can't survive without it.
Hmm.
I mean, that's the bottom line. It goes back to why it's so important because drinking water is so critical. It kind of goes back to my earlier point of why it's so important for states and local jurisdictions to look to replace their leaky, antiquated water infrastructures that, in some cases, may even include lead piping. That, as we all know by now, can result in health issues, especially in children.
Hmm. So you mentioned funding too. So that kind of brings me to the next question. With the bipartisan infrastructure law. So is that having any impact on improving U.S. water infrastructure, and why or why not?
I would say yes. It was enacted in November of 2021, and so we're now about 14 months after its enactment. I would say we have made progress as the 1.2 trillion in funding has been made available through this bill. It does continue to help revitalize our water infrastructures as lead water service lines are being replaced throughout the country. I also hear that water utilities are reinvesting in their networks, from updating risk management plans to better preparing for emergency hazards. Um, that said, however, the long-term needs quite simply outpace the record-setting funding that Congress established in this law. In fact, in 2021, the EPA projected that the capital costs associated with wastewater and drinking water infrastructure needed to meet federal water quality and safety requirements and public health objectives exceeding 744 billion over a 20-year time period. So obviously, the bipartisan infrastructure law will only tackle a fraction of these costs, which is further limited by the fact that some of the funding is in fact going towards forgiveness of existing loans drawn against the Clean Water State Revolving Fund, the Drinking Water State Revolving Fund, both administered by the US EPA, rather than investments in new infrastructure starts.
Okay. So that was kind of into my next question. Many, not only yourself, but many other plumbing industry experts I've heard from have expressed the same concerns regarding the funding not being enough to tackle the momentous, project ahead of us in replacing infrastructure. So, what do you think needs to be done to help, create that funding pool to, better our infrastructure?
That's a great question. Yes, as I've said, I do think we're making progress, but I do tend to agree with the experts. Although the 1.2 trillion is helping, the question is how much. The American Society of Civil Engineers has previously stated that the government needed to invest around 3.6 trillion in the infrastructure alone by 2020, which of course it did not accomplish with the bipartisan infrastructure law.
Hmm.
What I can tell you as far as the International Code Council, we are currently working on cutting edge plumbing research with academia and practitioners to develop modernized plumbing standards, which, when combined with more efficient fixtures, water reuse, and on-site water disposal, will reduce the strain on existing water infrastructure. I believe that the combination of advancements in efficiency, reuse, and on-site disposal with the investments of the bipartisan bill will ensure these federal investments are more impactful than they would have been if Congress simply provided the funding absent of any complementary work on the part of plumbing and water industries.
Okay.
And I would just add your second part, because it was really a two-part question about, well, what else needs to be done?
Hmm.
Um, I'm going to tie this in more to beyond a little bit of water. I'm going to touch into wastewater and stormwater briefly here.
Okay.
I really think there's a need to focus on our sanitary sewer pipe systems. In the bipartisan act, it requires EPA to establish a new program to provide grants to nonprofits for the construction, repair, or replacement of individual decentralized wastewater treatment systems, aka private sewage disposal systems,
Hmm.
which the Code Council, of course, supports and we're doing things about. But what about centralized wastewater systems, such as public sewers? It really doesn't talk a lot about that. In fact, the American Society of Civil Engineers has estimated that aging pipes and the inadequate capacity of public sewers has resulted in the discharge of about 900 billion gallons of untreated wastewater into waterways annually.
Oh, wow.
Um, I would say the other thing is utilizing smart technology for underground systems. Most of this is underground, can't see it. And I'm sure there's utilities out there looking at this, but it needs to be more widespread. By utilizing sensors and other types of smart technology, they can predict infrastructure failures in order to make informed decisions. Going back to my recent trip to Israel, that's how they stay on top of their aging water and wastewater infrastructures. They have sensors and use smart technology. Without it, there's no way they would know what's going on.
Yeah, that makes a lot of sense. So, given the growing effects of climate change and these extreme weather patterns we've been having, especially if you look at California recently, how can the U.S. ensure our water infrastructure can withstand or quickly recover from natural or man made disasters?
Great question. Again, I really believe it starts with the replacement of our aging water supply, wastewater, stormwater infrastructures, because in a lot of cases, these systems are quite vulnerable due to their age. And I believe installing modern piping materials would definitely make a difference in performance when natural disasters do occur. I also think that it's important that utilities set up regular schedules for replacement of infrastructure. Again, I know it takes money, but and again, the time frame. I'm not saying we have to be as aggressive as Israel, but I do think it's important that we take this under consideration because we're now. I mean, we've got pipes that date back to the 19th century in this country. Big cities, New York, Boston, Chicago, that's just not good to have. And we're noticing issues with lead poisoning, issues with the spread of waterborne pathogens such as legionella. This is all tied together. We need to figure this out on how we can have regular scheduled replacements of our infrastructures. Again, I know it takes money, but it also means that we're going to need to start prioritizing this in this country.
Hmm. So that kind of leads into the next question. How can the plumbing industry help solve these issues? Because these are the people who are working on these systems, designing these systems. What can they do to, help make our water infrastructure, better?
Um, Well, there's a lot of efforts going on right now to, around water efficiency, water reuse, all being promoted by the plumbing industries and many associations. I would think one thing we could do, and again, it addresses our most vulnerable population, is our children.
Hmm.
I think we could do a better job of encouraging schools and childcare centers to enact lead remediation programs that would require endpoint devices that are used for drinking and cooking purposes to comply with the latest version of NSF 61, which deals with drinking water system components and their health effects. And not only adopt the latest version of Industry 61, but making sure you're, not even based on the year, but making sure that the version that you're adopting also reflects the more stringent lead leaching requirements that are now in the standard. They keep updating NSF standards all the time, but it's important that the new lead leaching requirements are enforced when selecting plumbing fixture fittings.
Okay. Well, that's pretty much all the time we had today. Was there anything else in general you wanted to add on the topic?
Yes, I would like to further expand upon the plumbing research that the Code Council is currently engaged in with the University of Miami,
Yeah.
which will be used in the development of our newest PMG-related ANSI standards, ICC 815 and ICC 825, and the kickoff of committee meetings for both standards in February, March of this year. ICC 815 will focus on properly sizing water, drainage, and vent piping and plumbing systems for residential, mixed use, and institutional occupancies based on not only the plumbing fixtures we use today, but how often we use them in our homes and businesses as well. And ICC 825 will address the design, installation, construction, operation, and maintenance requirements for private sewage disposal systems that are resilient to extreme weather events caused by climate change.
Okay. Well, I hope you'll keep us updated on those and how those are progressing.
Absolutely.
Well, thanks again for taking the time today, Matt. I appreciate it.
You bet. Thank you.